Assalamualaikum viewers, please like, share and subscribe this channel. Links of PDF files used in this video are given in description. So today's lecture is about metallic bonding and we will explain this type of bonding by using electron pool or gas theory, VBT or hybridization concept and MOT or band theory. Metals are already a solid type of material, but we cannot explain the bonding in metals by usual casual theories. So we take the help of special theories such as electron pool or gas theory, valence bond theory or hybridization theory, and MOT or band theory. So collectively, all these theories explain the type of bonding which exists in metals. So overall, if we talk about the chemical bonding in crystalline solids, so there is ionic bonding in which there is formal positive and negative charge on the species and these attract each other. Then there is covalent bonding in which mutual sharing of electron pair occurs and the orbitals are formed, and these orbitals arrange in particular direction or geometry to form structures. Whereas this is the metallic bonding, and it is a special type of bonding which will be discussed in detail in this lecture. And fourth one are the van der Waals forces, and these forces are very weak forces, and these are also developed between the dipoles, and sometimes these dipoles are produced for just an instant. So in this way, these are four types of bonding forces which exist in crystalline solids. However, our focus will be on this type of bonding which is called as metallic bonding. Metals have very distinct characters, such as there are very conductive materials, thermally conductive materials. Similarly, we can deform them into different shapes very easily, and they have metallic luster. So all these properties need some special theories to explain the bonding in metals. So if we take the scanning electron microscope image or SEM image, so we are seeing here the atoms of some metals. So it appears that these atoms appear in the form of spheres. So all these types of bonding situations, we have to address these characteristics, and that is why we are starting our lecture with electron pool theory or electron gas theory. According to this theory, the metal atoms actually, these are just like spheres. These metal atoms lose their electrons, as in the definition of metal it is said that metals are those atoms which lose or tend to lose their electrons. So these are the atoms after losing their electrons. So these red balls are actually the electrons. The metal atoms converted into metal ions or spheres, and sometimes these are called as kernels. So these kernels or metal spheres, they remain fixed or studied, they don't change its position. However, the electron which these atoms lose, these electrons are mobile and they can move from one atom to other. So that is why the name comes electron pool theory or electron gas theory. And the basic concept of this is that atoms lose their electrons and they remain fixed or studied in the pool or gas of electrons in which these electrons are delocalized. It means they are not they are not fixed in their locality. These move from one place to another, so these are delocalized, whereas the metal ions remain fixed, studied or localized. So one major property of metals is their electrical conductivity. So how this electrical conductivity is carried out: if we attach with metal sheet the negative side of electrode or battery terminal, and here we have attached a positive side of terminal. So here there is a negative charge, so these the electrons present in this position, they will repel from this position and they will move forward, and they will move forward towards the positive terminal of the battery. And in this way the electrons are flowing from one direction to another direction in a regular manner. So the flow of charges is called current. So in this way, when we attach the battery terminals in the some metal sheet, the electrons because these are delocalized, these are not fixed, these are movable, these are a pool or gas, so it is movable, so the movement cause electricity or electrical conductivity in the sheet. So in this way, the electron pool theory or gas theory helps in the justification of electrical conductivity of metals. Now if we also heat this sheet, then what will happen, that electrons present in this position, they will absorb this energy and they will move to different directions in a random motion, and this random motion restrict the continuous straight directional flow of electrons, so as a result of which the electrical conductivity will decrease. So this also explains that how the thermal heating decrease the electrical conductivity of metals. The next prominent property of metals is thermal conductivity. So if we heat one side of the metal, so we can sense that heat at the other side. The reason is that the electron or pool of electrons, so these electrons absorb heat and their kinetic energy is increased, and they give this kinetic energy to neighboring electrons, so these electrons move, and as a result of which their movement, the heat is transferred to the other end of the metal part. So in this way, due to the mobility of these electrons, the heat is conducted from one side to the other. So this theory also well explains the thermal conductivity of metals. We know very well that metals under the action of force can be converted into sheets or wires, which is we call it as ductility and malleability of the metals. So how this happens, when we force this area with some external force, so as these atoms are converted into positive spheres and they are placed in this negatively charged pool or gas, so as the force is applied, so all the atoms slightly move forward at the region where the force has been applied, because all the atoms are present in the pool or gas of electrons. So due to the mobility of electrons or the pool of the electrons, the sheets are deformed and metals can be converted into wires or sheets. So in this way, the property of matter deformation can also be explained with the electron pool theory or gas theory. Next important property of metals is metallic luster. Like when metals are freshly cutted into pieces, then their internal surfaces are very shiny in nature. What happens, that the electrons absorb energy and they go to high in an energy state, and when they comes from this high energy to low energy, then they emit in the form of light, and this light will appear, and it appears that metal is showing its luster. So the metallic luster is due to the de-excitation of electrons from high energy levels to low energy levels. So in this way, all the major properties of the metals are well explained by electron pool theory or gas theory. Metallic bonding can also be explained by valence bond theory or hybridization theory. For example, here in this picture, we have explained the bonding between different layers of metals of lithium atoms. So here we are seeing that between these atoms, a single common sigma bond is formed by mutual sharing of electrons. In place of downward bonding, the bonding can play sidewise. So here we can see that sidewise bonding has been takes place. So it means the actual structure is the resonance contributing structure of these two forms. So this is the one concept of hybridization theory. Now this bonding situation can be explained here. So if we say here, this is the atomic number of lithium, so this is its complete configuration, which is 1s2 2s1 and 2p0. so this is the valence shell, and we shall have been written this valence shell in the form of valence bond theory. So here is 2s1, whereas 2p is empty. So 2s1 of one lithium atom will overlap with 2s1 of other lithium atom. So in this way, this bonding situation has been explained. But the question is that if there is a single bond between two atoms, either downward or sidewise, then how the metals are so much strong. So the strength in bonding cannot be explained by assuming only a single bond between two metal atoms. So the other thing is that if this lithium atom loses electron and this electron is gained by this lithium atom, so it will be converted into positive, whereas this lithium atom will be converted into negative form. Now this has two unpaired electrons, so it can combine with two other atoms. So in place of one bond there are two bonds formed, plus third an ionic bonding is developed between these two elements because of the presence of charges. So not only this one structure is formed, but it can be formed in this way, in this way, or in this way. So we can see that overall in the whole metallic lattice the charges are moved from one place to another. So this is also this concept is matching or strengthening the a proposal by electron pool theory or gas theory, in which it has been stated that electrons are movable while the metals are fixed or studied. So in this way we are seeing that negative charge is present here, so we can say negative charge has moved here, here it has been here, and it has been here in this way. And due to these movement of charges, the electrical conductivity, the thermal conductivity, the metallic luster, and that metal deformation, all properties can be explained by this movement of charge. Now how this particular structure is formed, now let's see the bonding situation of this case. So in this case, if we see here that the neutral lithium atom has only one electron, but if we create a negative charge then we have to place an extra electron. So this electron element loses its electron and it is gained by this. So this has been represented here. So now this is lithium negative, and this is its excited form, it goes to p sharp. Now this is the Li excited state in negative form. So these are its two unpaired electrons. So one lithium atom will overlap with its atoms and the other will overlap with the unpaired electron that is present in p. So in this way one lithium negative makes a bond with two other lithium atoms. So this is the concept of hybridization theory, which explains the metallic bonding, and it is somehow coherent with the postulates that has been presented by electron pool theory or gas theory. Third theory which explains the metallic bonding is called as molecular orbital theory. This theory is also called as band theory. Why this theory is called as band theory? Let's see. This is the single atom, and if we see here that this is its 3s orbital and this is 3p orbital. So if we collectively write these orbitals for 5 closely placed atoms, so these are the 3s orbitals of 5 atoms and these are the 3p orbitals of 5. Similarly, if in a mole approximately 6.02 into 10 raised to power 23 atoms will be present. So if we stack all the 3s and 3 orbitals, so these are so much close to each other, then we will not call it as single orbitals or single lines, but these will be so merged together, so we will call them as bands. So here comes the name of this theory, band theory, which is that when there are many number of atoms, so their orbitals come so close together, so they make a band. So that is why we call it as a band theory. So if we talk about the electrical conductivity, the materials are divided into three types, which is metals, semiconductors, and then last insulators. In metals, if we see here that there are two bands, the red region is called as the valence electron bands, and which is filled with electrons, and this is the band which is not filled or which is empty. So if we are seeing here that filled band is overlapping with the empty band, so it means there is a space, electrons can move freely in these metal orbitals which are empty. So that is why we call it as metals. In semiconductors, actually there is a gap between the filled orbitals and empty orbitals, but this gap is not so much, and by adding extra factors we can narrow this gap further and make semiconductor conductive. So this gap is not so much greater, and we can surpass this gap by adding certain extra factors. But in case of insulators, the energy difference or the band gap between the filled electrons or orbitals and between the empty orbitals is so much greater that it cannot be filled by any factor. So that is why the insulators are not able to conduct electricity. Semiconductors are in between the metals and insulators, and whereas the metals, because they have the free movement of electrons in the empty conduction bands, so they can conduct electricity. So the Fermi level means the level below which all the energy levels are filled is called as Fermi level. So this is the situation in three types of materials according to band theory. Now the semiconductors are two type: extrinsic semiconductors and intrinsic. In intrinsic semiconductors there is so much less gap that it can be easily overcome by providing some light energy or some heat energy, etc. But in extrinsic semiconductors we have to do some doping. So this doping can be of n type and this doping can be of p type. In n type doping we add extra electrons. So in this way, now this is the Fermi level. So the electrons can easily move from this Fermi level to the conduction band and the electricity or electrical conductivity happens. Whereas in case of p type materials we create holes or empty conduction band here artificially. So this is the Fermi level. So electrons move from this level to upward, and in this way conductivity occurs. So in this way the semiconductor material can be converted into some conducting material by adding n type or p type doping. So this type of material is called as extrinsic semiconductor, in which we have extra added some things rather than their internal system. So this is the n-type material, and this is the band theory explanation, in which this is the valence band in which the electrons are filled, whereas this is the empty conduction band. The electrons cannot jump from this place to this place. However, electron can jump from this place to this place easily. So by doing extra electrons here, we can make this Fermi level, and electrons can easily jump from this place to this place, and the conductivity increases. So this is the n-type material explanation, theoretical explanation by the band theory. Now what we do in practical? So here are the silicon atoms. This is the intrinsic semiconductor, and we make it an extrinsic semiconductor by adding extra electrons. So what we will do, we will dope it with some other atoms such as phosphorus atom, which has one more electron as compared to the valence electron of silicon. So if we are seeing here that phosphorus actually contain 5 electrons in its valence shell. So in this way it has one extra electron as compared to silicon, which has 4 electrons in the valence shell. So this electron create n-type doping material. So it create extra negative charge or electron, and this extra electron is represented here by band theory. So in this way this Fermi level is formed, and now electrons can jump freely and easily without any force from this Fermi level to conduction band. So this is the explanation of n-type material. Similarly, we can prepare p-type material by adding some extra holes or positive charges. So this is the explanation of MOT of p-type material. Again, here is the filled energy level, this is the Fermi level, and here the electrons are filled, whereas this is the empty conduction band. So electrons cannot move from this valence band to conduction band. However, if we lower down the Fermi level, how we can lower down the Fermi level? By extra adding holes or spaces or the paths for the movement of electrons. How these holes can be created in experiment? So let's come here. So again, this is the silicon, which has 4 valence electrons in its valence shell, whereas we will dope with the boron. It has only 3 electrons in its valence shell. So here comes the hole, as a result of which, or positive charge, this hole has been represented here, and in this way this is the Fermi level. Now the electrons in the valence band can easily jump into this hole region or empty conduction band. So in this way, now rather than this conduction band, here comes the conduction band, and electrons can jump freely to this conduction band or area or small holes. So in this way, this is the explanation of, or MOT explanation or band theory explanation of p-type material. So in this way, we explain the bonding situation in metals by using these three theories, including molecular orbital theory, then valence bond theory, and finally electron pool theory or gas theory. So I hope you have well understood this lecture, but still if you feel some confusion or have some questions, do let me know your queries in the comment section of this video. I will respond to your queries as soon as possible. Okay, thank you. Allah Hafiz.